For our final example of the day, we are going to look at finding all of the real solutions of this polynomial, x to the third minus 8x squared plus 11x plus 20 is equal to 0. This is going to be a grouping fail just like my last one. You can prove it to yourself if you'd like, or you can just take my word for it. So I'm going to do the same thing I did last time. With p of 20, I'm going to have 1 and 20, 2 and 10, 4 and 5. And since q is just equal to 1, my leading coefficient is a 1 here, my factors of 1 are, well, simply 1 and 1. That's going to make this one a little bit easier than the last one because I don't have two q values. Well, I have the same q value twice. So the first thing I'm going to do is, just like before, I'm going to find all of the possible solutions, the possible p over q values. So I can say plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, and plus and minus 20. Again, that is every p value that you see here divided by the q value of 1, which is the only q value in this case. Now, in order to figure out which one actually is a possible solution, I need to test these. And the way I'm going to test is with synthetic division. Because remember, if we get a remainder of 0, then we know that we've found a factor. So let's just start at the beginning. I'm going to start with x equals 1. And so I'm going to try and divide my polynomial by the factor of x minus 1. Remember that it's the opposite. Draw my synthetic division box and see if I need to add any zeros. 3, 2, 1, 0. I have everything accounted for. I can just write my coefficients. 1, and then negative 8, 11, 20. You should be super quick at synthetic division by now. I'm not going through every step. Bring down the 1, multiply by 1 to get 1. Negative 8 plus 1 is negative 7. Multiply again to get negative 7, which adds to 4. And then 4 and 20 adds to be 24. Well, 24 is not 0, so this is a no. And so we have to continue testing additional possible solutions. Well, I've tried 1. Let's go ahead and try x equals negative 1. So now I'm going to take a negative 1 and divide everything. Same coefficients as before, but now I have a negative 1 that I'm going to be dividing by. Bring down the 1. This gives me a negative 1, which adds to negative 9. Positive 9 adds to positive 20. And then 20 times negative 1 is negative 20, and I get a 0. All right, that's what I was looking for. This is a big yes. That means that negative 1 is going to be one of our solutions, or that x plus 1 is a factor. So let's use that fact that we know x plus 1 has to be a factor, and the rest of our polynomial, what we have left, is this right here. So let's go ahead and label everything. We know that our remainder is 0, constant x, and x squared. So the rest of my polynomial, what I have left after I pull out x plus 1, is x squared minus 9x plus 20. And remember that all of this is equal to 0. So now I can continue to factor. I notice that I have a quadratic, so I can use my quadratic factoring. Also, what's nice is that my a value is 1, so I can simply say what are two numbers that multiply to be 20 but add to be negative 9. That would be a negative 4 and a negative 5. and set everything equal to 0. So now I have 3 linear factors. That means I'm done factoring and I'm ready to set each piece equal to 0 and solve. X plus 1 equals 0, x minus 4 equals 0, x minus 5 equals 0. Well, we already knew this first one, x equals -1. We proved that with synthetic division. This one will be x equals 4, and then finally x equals 5. If you were asked to, you could go ahead and graph this the way that we did previously, but in this particular case, we're not asked to do that.